Okay, so this is number one of this week's review of derivatives. So on this first one, I'm going to use the product rule, right? I have f of x equals the product of two terms. In this example, my first function is x squared, and my second one is the root of 2x plus 1. So you have to remember that if you take the product rule says that if you knew the derivative of a product, I'm going to try to write here, the derivative, it's the product of the root of one times the other plus uv prime. So I'm going to do that here. My first term is x squared, so the derivative of that, I'm going to write here the derivative of f is the root of x squared, which is 2x, times the second term, very ugly x, sorry, then plus the x squared, doesn't have a derivative of that, times the derivative of, I think of this guy like 2x plus 1 to the 1/2, right? That's the trick to do these. So let me erase this, what's going on here. I'm going to think of it like 2x plus 1 to the 1/2. So I do like I think it's called the Generalized PoW rule. So the derivative of this thing, let me write like this, is just the 1/2 comes down, then the 2x plus 1 to the negative 1/2 because it's to the minus 1. And I'm not done yet. I still have to find the derivative of the inner function using the chain rule, right? So still times the 2. So I'm going to write that here. So I just did it on the side to explain that. See it that way? It just becomes, so x squared times, I'm going to write it down. So 1/2 times, to negative 1/2 becomes something in the denominator. I can write it like this. And then the 2 that's right there, so I can put it anywhere I want. I'm going to sneak it in right here. That's that 2. That 2 is going to cancel this 2, right? So, so at the end, my first derivative is, let me scroll up. My first derivative really becomes 2x times this square root plus x squared over this square root. So that's the first derivative, and now the problem says to find the first and second derivative. So this is the first one. Done. Now let's find the second derivative. So if this is f prime of x, now I have to do the second derivative. And for the first part, I'm going to do again the product rule, right? So this is my first function, that's my second function. The derivative of 2x is just 2, then times the root of 2x plus 1. And then the same thing happens, right? I'm going to have a 2x that's multiplying the derivative of the second function, which I already did it, so I'm going to be to the 1/2, so it's going to be 1/2 times that to the negative 1/2. So it's going to go down here. And then the derivative of the inside function, which is still another 2 up there. Right, so this is the same thing we did above. Only that now the product is 2x and not, the other factor is 2x and not x squared. Okay, so this is this part. But now I just did the product rule. All I've done so far is the product rule on these two terms. Right, I still have to find the derivative of this guy. So this product rule becomes this times this and this times that. Right, these two terms came that. But this one I still have to do the derivative of this other one. And for this other one, I need to do the quotient rule. So if you recall what the quotient rule is, let me write it up here if you want. The quotient rule says if you have a quotient that is the derivative of the top times the bottom minus this times the derivative of the bottom over the denominator squared, right? So let's do that here. Okay, so the derivative of this will become the derivative of the top, which is easy, it's a 2x, times the bottom, which is the square root of 2x plus 1. Oops, sorry, big zoom right there. Erase this, and let me erase this little 2. So it's 2x times, let me scroll, zoom in, something like that. 2x times, I need to see my function, it's right there, okay. 2x times the square root of the 2x plus 1. Then minus the x squared times the root of 2x plus 1. So we already did it several times. So it's going to be 1/2 times a root, sorry. the root of 2x plus 1 in the bottom times the 2 in the top, right? And again, these 2's cancel. But all that has to be divided by the denominator squared, which was, since I have 2x plus 1 inside our root, when I square it, it just becomes 2x plus 1. So I can erase this guy. So this just becomes 2x plus 1. Okay, so this is it. This is the second derivative. If we stop here, we're kind of okay. We just, sorry, I just cancels. We just gonna simplify a little bit, and we can do a little bit on this part, right? There's not much to do on these, although here 2 cancels as well. So let's work each piece and see how much we can simplify. The first term, of course, doesn't simplify at all. The first term stays as is. So this term is just 2 times the square root of 2x plus 1. On this term, I can cancel one of these 2, so I get a 2x over a root of 2x plus 1. And that's just because I can put this guy over 1 and I'm putting multiplication across for the fractions, right? And the third term, there's still some work to do if I want to simplify this. So the denominator is already equal. It's 2x plus 1 without a root. Just going a little bit sideways, so let's do it like this. The first term, of course, I'm going to keep it as is. I'm going to try to focus on this part. So I have 2x times the root of 2x plus 1. Then I have a minus, and the x squares, these 2 cancel, have an x squared on the top over 2x plus 1. I think that's what I have so far. So now, this looks good, but I have so many roots of 2x plus 1s here that there should be a way to combine these. So let me work this out here. Let me not copy the other ones for a little bit, just work on these. So this second part here, I'm going to do something here, use the advantage that I have this tablet. So I can write this like 2x times the root of 2x plus 1, a little bit floating around, because I want to see that what I'm going to do is put these guys in the same denominator. So this guy right now has a 1. So what should I use the common denominator? Well, the common denominator is exactly this root of 2x plus 1, right? The common denominator is exactly the root of 2x plus 1. So that means that I'm going to multiply this guy by a root of 2x plus 1, which means that I'm going to just erase this guy, right? This is going to become, this part is going to become 2x, sorry, this still has this guy down here. So this is going to become 2x times 2x plus 1, because I'm going to square it, right? I'm going to multiply it by itself, minus x squared. And then all this is over 2x plus 1. And this is a numerator, right? This is the top. Let me be sure if I can follow this. This is the top of that. And I put those 2 fractions on the top and the same denominator. And now the bottom still has a 2x plus 1 here, which I'm going to write now like over 1, if you want to see it. So then I can work this out, because now if you look at this carefully, if you know what's going on, then I can do this saying, oh, so this really becomes, had an equal sign. Oh, what happened? Sorry. We're out of control here, but here we are. So now the top becomes 4x squared, if you used to use that, plus 2x minus x squared. Yeah. Then I think I had over 2x plus 1. Over 2x plus 1 over 1. I'm putting this denominator like this so you can see that at the end I'm going to multiply, flip this guy, and multiply like 1 over 2x plus 1. Sorry, I think I missed something that's weird here. This guy should have a root on it, right? Yes, this is this one. So now this one has a root right here. So if I erase the 1 in the bottom, flip it and multiply by the reciprocal, it becomes this. And there you go. So your final answer would be 4x squared minus x squared. I get 3x squared plus 2x over 2x plus 1 to the 3/2. Right, this is to the 1/2 and to the 1, so it's to the 3/2. That's this part. Oh, sorry, I shouldn't have that equal sign. Because that's just this part, right? These terms should still come down. These are not changing. So your final answer should be these two terms added with that term. So let me write it down here. So this term should be 2. We have a 2 root of 2x plus 1. And the second term was 2x over the root of 2x plus 1. And this is my third term. This would be the second derivative. Okay, so it's a little bit of work, but that's the whole point. I need to practice a lot of the rules in this one. I hope this helps you review what kind of stuff we needed to do. We did the product rule, the chain rule, and the quotient rule on this one. Okay.